The image already looks complete. That is the first mistake. Thousands of points of light sit against a black background. The frame appears frozen. Self-contained, finished. For a moment, it feels like a direct view of the universe. Then one stretched arc refuses to settle into the scene. Then one stretched arc refuses to blend in with the rest. Nearby galaxies look compact and familiar. This one looks pulled apart, as if the light itself was bent before it reached the telescope. The light in that distorted shape did not leave recently. A time marker pushes backward. More than 13 billion years. The picture still looks present. The galaxies still appear to exist together in one frozen moment. Yet the evidence inside the frame arrived from different depths of time. What looks like a direct view is actually a collection of signals that survived the journey. The image remains beautiful. The light remains late. In James Webb's SMACS 0723 field, gravity bends the background light. The nearby galaxies appear compact and rounded, but this one shape stretches into a thin arc, almost as if part of the image has been pulled sideways. The view lingers there. Nothing else seems unusual. A simple overlay traces the path the light likely followed. The line curves as it passes through the cluster, not because the distant galaxy changed shape, but because the mass in front of it changed the route the signal took before it reached us. SMACS 0723 is about 4.6 billion light-years away. The cluster sits in the foreground, and its gravity quietly redirects light arriving from much farther behind it. What looked like a strange object begins to look more like altered evidence. The arc is not merely something being observed. It is something being revealed by an invisible process that happened along the way. The signal did arrive, but it did not arrive untouched. A set of guidelines appears across the image.
The reconstruction of the
They follow the
SMACS
stretched arc,
0723 field is complete.
trace its curve,
All gravitational
and connect it
arcs
to the
and
mass
distant red
sitting in the
sources are
foreground.
resolved.
For the first time, the distortion starts to look less like damage and more like something that can be measured. James Webb uses infrared light in the SMACS 0723 deep field. Colors begin separating the scene. Brighter foreground galaxies remain clustered together, while faint red sources emerge farther behind them. Some are so distant that ordinary visible light would not have revealed them clearly at all. The arc is no longer treated as a mistake. It becomes part of a map. The guide pattern grows more complete. The bent light, the foreground mass, and the distant source begin fitting together into a workable picture. Webb was designed to observe infrared light from the early universe, and within that infrared view, galaxies formed during the first few 100 million years after the Big Bang start becoming easier to identify. For a moment, the image feels stable. The reconstruction appears to hold. The guidelines fade away, leaving only the field itself. Most of the scene still makes sense, yet one faint red point remains slightly outside the clean pattern, dim and isolated against the darkness. Nothing about it looks dramatic. It simply stays there after the model is gone. In James Webb's first deep field, the route of the light can be explained. A model traces the signal from a distant galaxy, through the foreground cluster, and finally to the telescope. For a moment, the explanation feels complete. A time marker appears beside the source. The line remains connected, but the source is now separated from the present by an interval that cannot be crossed. Webb's first deep field targeted early galaxies through a foreground lensing cluster, and some of that light began its journey when the universe was far younger than it is now. The explanation still works. It simply arrives at a different problem. The path can be reconstructed. The distance can be estimated. The structure can be studied. Yet the object at the beginning of the line cannot be checked in its current state. The image returns to the faint red point. Nothing about it changes. The signal still reaches us. The model still describes how it arrived. What remains unavailable is everything that happened after the light left. The universe is about 13.8 billion years old, and that small red source stays fixed inside a moment that has already passed. The image returns, exactly as it appeared before. James Webb's first deep field was only a tiny patch of sky. Held at arm's length, it covers an area no larger than a grain of sand. Yet within that small space, the foreground cluster, the warped arcs, and the faint red galaxies no longer appear to belong to a single moment. They separate into layers. One layer sits closer. Another arrives from farther away. Another reaches us only after crossing the lensing cluster. The first Webb deep field was presented as the deepest infrared image of the distant universe at its release. But the image now feels less like a discovery and more like a record assembled from different times. Nothing in the frame changes. The meaning of the frame does. A comparison appears beside it. A grain of sand held against the sky. That tiny patch contains enough distance and delay to turn observation into history. The clearest image does not remove the gap between us and the universe. It reveals the gap. The image was already too late.